Hi, let's do some more examples for finding the absolute max mean of a given function on an interval. The function here is x plus 2 cosine x on 0 to pi. Well, we'll start with the critical numbers. So here f prime of x is equal to 1 plus 2, minus 2 sine x. We set it equal to 0. This gives us sine x is equal to 1 over 2. Well, this has infinitely many solutions, but the ones which are in this interval is, well, pi over 6, sine of pi over 6, and 5 pi over 6. These are two values of x at which the sine is 1 over 2. As a result, f prime is 0. So those are critical numbers. Then we evaluate the function at these critical numbers. F pi over 6 plus 2 times cosine of pi over 6. This is pi over 6 plus 2 root 3 over 2, which is pi over 6 plus root 3. At 5 pi over 6, this will be 5 pi over 6 plus 2 cosine 5 pi over 6, which basically gives us this time negative root 3. Well, we need to evaluate the function at the end points also. So f at 0 is 0 plus 2 cosine of 0, which is equal to 2. F at 2 pi is 2 pi plus 2 cosine of 2 pi, which is 2 pi plus 2. Now we have to compare these values, yes. First, this guy here is the highest value. 2 pi is a number about 6.28, and plus 2 is 8. None of the other numbers are about that value. Let's see, for example, if pi is 3.14, so approximately pi over 6 is going to be 0.5, let's say 2, yes, plus root 3 is about 1.7 something, so let me just write 1.7. Together these will add up to 2.20 something, yes, so a little bit below 2.25. But if you do the same approximation, almost the same approximation here, you will notice that 5 pi over 6 is going to give us some number like 2.6 something. Oh, well, this is approximately, yes, minus 1.7. This is definitely a number which is 0.9, definitely less than that number, yes. And this is the smallest number we have here. So compare the values, and you see that f has absolute max value of 2 pi plus 2 occurring at 2 pi, and then the absolute mean value of 5 pi over 6 minus root 3, which occurs at 5 pi over 6. Critical numbers, evaluate, and then compare the values. Let's do this last example here. Well, again, we will start with the critical numbers. F prime of x. Well, differentiating these guys, it will be not a different thing than the other ones, but you have to use the product rule. Derivative of first one plus times the second one plus the first one times the derivative of the second one. And well, if you do the computation, you can factor out what? X minus 2 and 2x plus 1 squared. Here you will see 2 times 2x plus 1 plus, in the second one we'll see x minus 2 times 6. And this is x minus 2, 2x plus plus 1 squared. And this is what? This is 4x plus 6x there. So that will add up to 10x plus 2 minus 12. And that is actually equal to a negative 10. And this, setting this equal to 0, gives us x is either equal to 2, x is equal to negative 1 over 2, or x is equal to what? 1. Yes, three critical numbers, but we have to be careful here that well, this negative value is not in the interval. So we have to throw that out. Then evaluate the function. So evaluate f at 1 gives us 1 minus 2 squared, 2 times 1 plus 1 cubed, which is equal to 9. Should be more than that, yes, because this is 3 to the power 3, and then there's, this is 27 actually. And f at 2 will be, 2 minus 2 squared, 2 times 2 plus 1 cubed. Well, this is 0. We also need to evaluate the function at the endpoints. We already evaluated at one of the endpoints. We need to do on the other endpoint. So this will be 0 minus 2 squared, 2 times 0 plus 1 cubed. Oops. And that gives us 4. 3 values, compare them. The highest value occurs here. So f, the absolute max of the absolute max value of f on the given interval 0, 2 is 27 and obtained or attained at x equal to 1. The absolute mean value, on the other hand, of the function on 0, 2 is 0 and is obtained at x equal to 0. So you find critical numbers, evaluate, and then compare. That's how you find the maximum, minimum, absolute max mean of the function at the given interval.